The quietly expanding reason your own bloodstream still carries a seafloor signature it refuses to let go of. And in 1977, near the Galápagos Rift, that same hidden growth split open a wound in the ocean floor that has never once stopped spreading. It's happening right now, under 70% of this planet, and the salt balance keeping your heart beating traces straight back to it. Here's what nobody tells you in school. The ocean floor isn't a static bowl of rock. It's a wound that never closes. Every single day, molten rock pushes up through a 40,000-mile crack that wraps around the entire Earth like a seam on a baseball. Scientists call it the mid-ocean ridge. You call it the bottom of the sea. But it's manufacturing brand new crust right now while you watch this video at roughly the speed your fingernails grow. That sounds slow. It isn't. Multiply that across 60,000 miles of open seam, running non-stop for millions of years, and you get an entire planet quietly rebuilding its own skin from the inside out. In 1977, the submersible Alvin dropped nearly 8,000 feet down near the Galapagos Islands, searching for warm water anomalies. What the crew found broke the textbooks open. Towering chimneys of black mineral smoke, boiling past 700 degrees Fahrenheit, surrounded by life that shouldn't exist. Tube worms 7 feet long, blind shrimp, clams the size of dinner plates, all thriving in total darkness with no sunlight, no plants, nothing photosynthesis could touch. These are hydrothermal vents. Cracks where seawater seeps down into fresh, still-forming crust, gets superheated by magma, and shoots back out loaded with dissolved minerals. Sulfur, iron, magnesium, calcium. That mineral cocktail is nearly identical to the electrolyte balance inside human blood plasma. Not similar, nearly identical. Some researchers think it's not a coincidence that life itself may have first ignited in one of these smoking cracks, billions of years before the first cell ever touched sunlight. But here's where it stops being a cool fact and turns into a problem nobody can fix. This spreading doesn't happen smoothly. It stutters. It locks. Pressure builds under the crust for years, sometimes decades, and then releases all at once in what's called a seafloor eruption, a full-blown underwater volcanic event, invisible from the surface, that can dump enough fresh lava to cover entire city blocks in a single week. In 1993, and again in 2011, seismic networks near the Juan de Fuca Ridge picked up swarms of thousands of tiny earthquakes over just days, then silence. When submersibles went back down, brand new lava fields sat where open water used to be. Nobody on the surface felt a thing. Nobody was warned. Here's the part that should actually worry you. Scientists have spent 70 years trying to model exactly when and where these ridges will crack next, and they still can't reliably predict it. Not because the technology is bad. Because the seafloor is doing something almost recursive. It grows, cools, cracks under its own weight, and remelts in cycles that don't follow a clean, human-readable clock. Some sections of ridge spread nearly 15 centimeters a year, fast enough to watch a new island form in a single human lifetime, like Surtsey did off Iceland in 1963. Other sections barely move 2 centimeters a year and then snap violently once every few decades, releasing energy equal to a mid-sized earthquake, entirely underwater, entirely unfelt. And remember that mineral cocktail from the vents, the one that mirrors your blood plasma. It isn't just sitting still down there. Ocean currents pull it upward into the food chain, into the fish you eat, into the salt cycles that regulate the entire planet's climate. The seafloor spreading under 7 miles of water beneath a ship you'll never ride is quietly rewriting ocean chemistry in real time, and by extension, rewriting the chemical balance every living thing on Earth depends on to survive. You are not separate from that crack in the crust. You are downstream of it. Every breath, every heartbeat, running on a chemistry the ocean floor is still actively deciding. And here's what keeps oceanographers up at night. If the rate of spreading changes, speeds up even slightly from increased mantle heat or shifting tectonic pressure, the volume of mineral-rich water flooding into the oceans changes with it. That shifts ocean pH, it shifts nutrient availability. It can quietly stress the exact microscopic plankton responsible for producing over half of the oxygen you're breathing right now. This isn't some slow-moving abstract climate trend. It's a mechanism buried under miles of water, invisible to satellites, unreachable by most submersibles, that can shift on a timescale of days once it finally lets go. And the last time monitoring stations caught a major spreading event mid-eruption, they only knew because of an earthquake swarm, after the lava had already cooled. So somewhere right now, under thousands of feet of black water, along a 40,000-mile crack circling this entire planet, new crust is forming in total silence. Nobody is watching most of it. No satellite, no sensor, no submarine. If a section big enough decides to let go tomorrow, releasing years of built-up pressure in one violent pulse, how long do you think it would take anyone to even notice? And what exactly is happening down there right now that nobody on Earth currently knows about?